Hi everyone, welcome to today's class on logic gates. Now, just like a conventional gate regulates the movement of people in and out of a particular environment, the computer also have a kind of gate that regulates signal and electric flow around its components. As we all know, the computer is a digital device that consists of various components such as the CPU, like the memory, the CMOS battery, and a host of others. There is a need to regulate the amount of charges that each of these components receive, because if the charge is high or is low, it affects their functionality. So there is a specified amount or quantity of charges that they need in order to function effectively. So if the electric charge is high or low, it affects their functionality. Now, on the motherboard, apart from CPU and memory, we have transmission channel or transmission routes known as buses. Now, these buses serve as channel through which this electric signal is being conveyed around the board. So each component receives its signal or electric charge through a bus. On the motherboard of a PC, we have what is called capacitors and transistors. They look like small batteries implanted on the motherboard. Now, their function is to regulate the amount of charges that each component receives in order to function effectively. You find motherboard in other devices such as handset, television, radio, and a host of others. Even chargers that we use for powering those devices use motherboard. So sometimes when you say charger got burnt, what actually happened is that instead of the current supplied, if it is high or low, instead of affecting the entire board, what happened is that the capacitor or the transistor will be affected. So they regulate current supply. If current is high or low, they regulate it. So instead of burning the board or burning other components, it is either the transistor or the capacitor that is affected. So in that case, what we do is just to change it. So they serve as building block for our motherboard. So you call them logic gates. They are like blocks, just like we build house. They serve as blocks for building. Now, pictorially, this is how capacitor looks like, and this is how a transistor looks like. So they have legs that are used to implant them on the motherboard. So if any of them is faulty, it can easily be replaced. So their function basically is to regulate the amount of charge that is being supplied to all the components that makes up the device. We have three types of logic gates basically. We have the AND gate, we have the OR gate, and the NOT gate. Now, both AND gate and OR gate uses two inputs, but the NOT gate uses just a single input. Now we'll take each of them one by one, and then we'll look into them in details. We'll begin with the first one, which is AND gate. Now, AND gate is a kind of logic gate that takes in inputs, which could be two or more, to give out an output of 1. And in this case, the two inputs have to be 1 in order to obtain an output of 1. If one or none of the input is 1, we will get 0 as our output. The OR gate. The OR gate is another kind of logic gate that function using the principle of addition. In an OR gate, when you have two inputs, it gives you an output. So if you have two inputs, either one of them or the both of them have a value of 1, we will always obtain an output of 1 because it uses the principle of addition. And lastly is the NOT gate. NOT gate has only one input, and the output is actually the opposite of the input. So that is why it is called as an inverter, meaning we get the opposite of the input as the output. So we only use one input in a NOT gate and we obtain one output also. Now, to understand AND gates, OR gate, and NOT gates, we use what is called truth tables that was derived from the work of a mathematician called George Boole. Now, on a truth table that have two inputs in an AND gate, X and Y are input, while Z is output. Likewise in OR gate. So from the AND gate, we see that we only obtain 1 if both of them are 1. In the OR gate, we obtain 1 if one or both of them has a value of 1 as input. And then for the NOT gate, we always obtain the inverse of the input. So for that NOT gate, we put in value of A, Y is the output. So if A is 0, Y should be 1. Now you may want to ask, why logic gates? Why are we talking about logic gates? Now we discovered that all electronic components such as our television, our radio, our handset all have motherboard. So all electronic components are resting on the motherboard. So there should be a system that regulates the amount of charges that these components use in order to function effectively. So in a nutshell, the device cannot function without the motherboard. The motherboard serves as